Så da har vi gjort det. Får vi se om recordingen blir bra, sånn at vi kan legge den ut på Yammer.
So let's see.
Jeg foreslår vi venter i 2 minutter til før vi starter.
Okay.
Det er fortsatt folk som dropper inn her. Det er sånn typisk på morgenskvisten. Så man kommer inn litt ikke akkurat helt på. Men sånn er det alltid i et linkmøte.
Absolut. Och framförallt första mötet på morgonen.
Yes. Så Lasse, du hadde lyst til å presentere en Friday joke, eller?
Nej, det var därför jag frågade om någon annan hade.
Ja.
Delete baklänges blir det roligaste jag kommer göra idag. Förutom massa roliga fakta.
Det er nok spennende som vanlig, det. Hardcore Active Directory. Okay, I guess we'll start. And Jimmy, you have the floor.
Okay, thank you. I'm sorry, I'm a bit, I have a cold today, so please bear with me. So we're going to continue on module 2 today on the AD architecture track. And today we're going to do some demos as well. And let's see how far we can get. So I'm just going to jump in on it if it's okay. Let's see if I can remove this. There you go. So we're going to first start talking about object deletions pre-recycle bin, because I know that not everybody has enabled it yet. So when data is deleted from Active Directory, the data can't simply disappear from the directory because the deletion must be replicated so that all domain controllers know of the deletion. Because what would happen if we didn't replicate the deletion, make them tombstone? The other domain controllers wouldn't know if a object is deleted or not. So what we do is, instead of deleting an object physically from the database, the directory service removes most of the attributes and then tags the object as a tombstone. And they do it by setting the isDeleted attribute value to true. This means that the object has been logically deleted from the directory but not yet completely removed. So the tombstones are replicated to communicate object deletions. The isDeleted attribute value alerts replication partners that the object has been deleted. Objects that are identified as tombstones are moved to the hidden deleted objects container of the respective directory partition. Tombstones remain in the directory for a default period of 180 days, which is referred to as the tombstone lifetime. And just some fun facts, Microsoft in Windows 2000, the default period was 60 days. Then with 2003, SP1, I believe it was, it became 180 days. Then they screwed up one of the service packs and it got back to 60 days. So if you have a 0 value from the tombstone lifetime attribute, you should actually set it manually to be 100% sure that you have 180 days today. So set the value manually if it's not set. So the garbage collection. Garbage collection is a process that runs on every domain controller to permanently remove expired tombstones from the directory, actually from the database. Although they represent deleted objects, tombstones can take up space in every directory partition and in all the replicas, so the tombstones themselves must be deleted to keep the directory database from growing without limits. So what happens is at regular intervals, objects that are no longer needed by the directory service are deleted as garbage. And in the way that is happening is that the garbage collection process, it deletes the tombstones. It also defragments the database file to compact data and optimize free space. And that is called online defragmentation. Garbage collection runs independently on each DC. When the garbage collection process occurs, the process finds the set of tombstones whose originating deletion occurred more than a tombstone lifetime ago. Sorry. So that means 180 days ago. And then it deletes each tombstone in that set. Two attributes of the directory services object, which is called NTDS service in the configuration container, control how garbage collection runs and what it removes. It do it as follows. So the tombstone lifetime determines the amount of time that the deleted object lives as a tombstone and in the directory before being collected as garbage. This amount of time is set in a tombstone lifetime attribute, and the default is 180 days. And the minimum setting is 2 days. So something you need to think about is you cannot purge tombstones before the expiration of the tombstone lifetime. I know there are tools out there that can, well, they say they do it, but if you do that, you can end up with a very, very messy AD. The garbage collection interval determines how often a DC examines its database for expired tombstones, so it knows what to be collected. This interval is set in the garbage call period attribute. The default setting is 12 hours and the minimum setting is 1 hour. You also have to understand that the maximum garbage collection interval is 1/3 of the tombstone lifetime in hours. So let's see if I can give you an example. So if you set tombstone lifetime to 30 days and the garbage call period to 300 hours, the actual garbage collection period is only 10 days, which is 240 hours. So if you look at tombstone lifetime and the AD backup and restore, so AD does not allow a restore from a directory backup that is older than the tombstone lifetime. Therefore, I recommend to back up AD at least twice during a tombstone lifetime. It's likewise important that the tombstone lifetime be substantially longer than the expected replication latency, so you make sure it has enough time to replicate throughout the whole forest. The default setting of 180 days for the tombstone lifetime is generous enough to accommodate unforeseen circumstances such as a van failure or a land failure or something like that. Because the expiration of a tombstone lifetime is based on the time when an object is deleted logically rather than the time when a particular server receives that tombstone through replication. That means an object's tombstone is collected as garbage on all servers at approximately the same time. So what it means is if I delete an object on DCA at 12 o'clock today and I have a DCB in Kuala Lumpur who don't get the replication until Saturday, it actually will be at that server will look at it was deleted at 12 today. So that's what it deleted logically. So if the tombstone has not yet replicated to a particular server, that server never records the deletion. Likewise, if you restore a domain controller from a backup that is older than tombstone lifetime, the domain controller do not have the record of some of your deletions. And this leads to inconsistencies among the DCs. Because if it has been garbage collected and purged from the database, no other DC will know it ever was there or was deleted. And I will go into details what happens with the lingering objects and so forth. So garbage collection scheduling enhancements. So what has happened since Windows 2000? From 2003 and upwards, the garbage collection removes a maximum of 5,000 objects per pass to avoid indefinitely delaying other directory services tasks. Which means if you have, think about you bulk load 10,000 users and you realized, oops, that was the wrong CSV file I used. So you delete all those 10,000 users. When it comes to the garbage collection, when it runs, it will only remove a maximum 5,000 objects at one pass. So instead of waiting a set of time to remove all the subsequent 5,000 tombstones, a domain controller continues deleting tombstone according to CPU availability. If no other process is using the CPU, garbage collection proceeds. Removing tombstone in this way keeps the database size from increasing inordinately as a result of the inability of a garbage collection to fully complete removal. So that means it removes 5,000 objects in one pass. Then it let AD do other replication and other work it needs to be done. And when the CPU is available, it will continue to remove as many as they can until AD still needs to do something else. And remember, this is pre-recycle bin. So garbage collection and linked attributes. So, when an object that has a linked attribute is deleted, although the object itself becomes a tombstone, the referent object does not reference the tombstone of the deleted object. Instead, will the link simply be deleted from the database. But when an object to which a link refers is removed as a referent, the link value for the removed object is marked absent and then replicated, very much like a tombstone. So let's say, for example, you delete the user and the user is a member of a couple of groups, and then you do the object in itself will not remove the linked attributes, or actually it will remove the linked attributes, but not the object itself, not the groups. The directory database, when you reanimate in tombstones, the database supports an LDAP API that reanimates the tombstone of a single object to avoid the necessity for an offline restore process in the event that an object is deleted unintentionally. So this basically means that Microsoft has an API, an LDAP API, that is available for creating applications so they can restore attributes that are preserved on tombstones. And those attributes are SID, GUID, and the security descriptor, as well as any indexed attributes. And when it comes to reanimation, you can only retain the attributes during a restore that is actually marked as to be retained, which is a search flag 8. Everything else must be recreated. So that means if you have deleted a bunch of users by mistake and you reanimate them and get them back up through this API, their group memberships, their email address, and so on and so forth will not be reanimated. Those information are lost. So actually, if you do the best way of doing to get these things back is to do an authoritative restore, especially if you have multiple objects, and I will show you how to do reanimation in a few minutes. The database system uses the quickest way to fill database pages. Although this system is efficient in searching and updating the database quickly, it does not make the most efficient use of space in the database. As write operations occur, the data pages fill, a certain amount of space often remains in a page that cannot be used by other transactions because the space is not large enough. In addition, space that is freed by version store cleanup is returned to the owning indexes or tables in non-contiguous chunks. So that means that free space that exists in the database is not always available for use because it is fragmented. So defragmentation rearrange how the data is stored in the database, compressing the data and making free space available in contiguous pages. Free space is managed automatically during database defrag. So the database defrag can take place online or offline. Offline is in directory services restore mode, and direct defragmentation has different effects on database size depending on whether defragmentation is run while the DC is online or offline. In short, online defragmentation, it occurs automatically. Online defragmentation compacts data, optimizes free space for database use, and thereby maintaining the file size of the database. Offline defragmentation occurs only manually. You do it in the restore mode. Offline defragmentation compacts data, returns free space to the file system, and thereby decreasing the file size of the database. So let's get in a little deeper about online defragmentation. During online defragmentation, space is partially filled data pages is reorganized to consolidate into full 8 KB pages. Any pages that have been skipped by version store cleanup or reclaimed for use by the database. Only defragmentation returns a freed page directly to the part of the tree, which is database, object table, index, or long value table, that owns the page that is being freed. When a sufficient number of contiguous free pages, they say approximately 16, exist in a given child tree, the space is released to the parent tree. So you need approximately 16 to free to the parent tree. So what you need to know is on domain controllers, online defragmentation does not reclaim free space that is deleted from long value tables. That's just something to think about. See, automatic online defragmentation. So ever since Windows 2000, DCs perform online defragmentation automatically, which means the EEC invokes online defragmentation after each garbage collection, which occurs every 12 hours by default. But you can also do a manual online defragmentation. On the main controllers running Windows Server 2003 and later, you can prompt online defragmentation to run manually. Although online defragmentation occurs automatically following garbage collection, and the garbage collection is known and configurable, the duration of the garbage collection process is variable. So depending how many tombstones have expired and the load requirements of the DC at the time of garbage collection. The variable nature of garbage collection can cause unpredictable performance between the time garbage collection begins and the online defragmentation completes. So why would you do manual? Yes, that's because when you perform online defragmentation during off-peak hours, you can ensure more even performance during peak hours. So control when online defragmentation occurs. You can configure DCs as following. You can actually start online defragmentation manually, irrespective of the garbage collection intervals. You can add the operational attribute do online defrag to the root DEC object. The value of this attribute indicates duration in seconds for which online defragmentation runs. After you set this attribute value, you can create a script that takes the duration as input so that online defragmentation can be triggered by the script at any time for any duration of runtime. So if you want online defrag to always occur only on demand, you can actually configure the registry so that automatic online defrag is disabled. I personally don't think you have to disable automatic online defrag to manually start online defrag. After you add the do online defrag attribute, you can start manually on the defrag at any time you want or when your conditions warrant it, but you also allow automatic online defragmentation to continue as well. So the few times I've done this, I actually used it as a value add thing. So if I have a lot of stuff that needs to be purged or actually garbage collected or defragged, I say, no, I don't want to do defrag on this big chunk of stuff that needs to be done during peak hours. I want to do it during the night. But I always let the automatic online defragmentation stay as usual, because it's every 12 hours, and if I do the big defrag during the night, it's not going to affect the peak hours so much. Offline defragmentation then. So as I said, the offline defrag rebuilds the directory database and releases unneeded space back to the file system. So offline defrag must be performed in the restore mode. In AD restore mode, you can use the entdsutil command line tool to defrag the entds.dit file. Offline defragmentation produces a defragment version of the database file in a separate directory. You can archive the original ntds file and move the defragment file into the current directory. And I see that as best practice. So before you actually start to defrag it, make sure you have a copy, put it aside, defrag it, and move it back on. So since only offline defragmentation provides a clear picture of the amount of space that is consumed by the database file, you can use offline defragmentation to test your database growth by comparing the defragmented version of the file and compare it with the fragmented version. So as an example, when I do it, I can have a newly installed domain controller. Then I perform a bulk load of objects, then defragment the database file offline. The difference between the two files is the space that is occupied by the new objects. And that way I can see how much 200 users actually, or they will take up nothing. Let's say 20,000 users. And depending on the attributes I choose to fill out, I can do comparison and see and do a calculation on the expectation of the ntds.dit file growth. But you also have to be aware there's no standard or optimal value for the percentage of free space that might exist in a database at any given time. So if you're concerned about database size, set the DSA log to log a message in the DS event log during the garbage collection that states how much this space could be freed up through offline defragmentation. Demo, object reanimation. Let's see if we can do this. Of course, that was the wrong one. Can everybody see my virtual machine? I hope so. Perfect. So here I have, just a dummy machine. I have my customers OU. I have AK, I got Anchorage, and let's do Gale Kitty. Oh, let's not do Gale Kitty. Let's do this one, Lena. So if we look at this user, we have a first name, last name, we have an email, we have a web page, we have some address information, some telephone numbers and so on, an organization. So what I'm going to do now, I'm going to delete her. Boom, there she goes. So I'm going to do reanimation, which I used LDP to do. Let's see if we can do this a little bigger. The first thing I need to do is connect to the server, which is demo1, port 389. I need to bind, and I bind as currently logged on user because I am a domain admin. So what I want to do now is see the deleted objects container. So let's do that first, and then what you can choose from is the forest domain DNS zone schema configuration and the actual demo, the domain partition. So you need to manually type in cn equals deleted objects. Boom. So I got deleted objects here, and when I'm going to expand this, you're going to see that I will see nothing. Oh, sorry. It's Friday and it's demo time. So I have no children. So in LDP, you have something called controls. So you need to load a predefined control that says return deleted objects. So no children, close it, double click it again. Here is my deleted objects. This is a pretty new installed domain controller, so it's not that many. I found Lena. So I want to modify Lena. And remember, this is pre recycle bin. So the first thing I need to do is I need to remove the isDeleted attribute. Put that in my entry list. Then I copy the whole distinguished name. I'm going to change the distinguished name. And I copy it in, and I'm just going to keep what I need, because when I change the distinguished name, I'm actually telling where I want to put this object back. So I don't want it to be in deleted objects. I don't want to have a Maggle name. That's what she's called. And she was in this OU, Anchorage. Which is underneath AK, which is underneath customers. So just spell everything correct. Make sure I have extended. We'll do this and we see what happens. Okay, what is not distinguished? I should do this. Sorry for that. So this is my two operations I will do. I will delete the isDeleted and I will replace the distinguished name with a new one. And we have a call modify. So I changed this, remove deleted, and if I go here, she's back with the same GUID, SID, and security descriptor. But as you can see, first name, last name is gone, phone number, email, web page, address, telephones, organization. Because those attributes are not preserved when you delete an object and it comes into the deleted objects container. But she's back. So what I need to do now is I need to check. You see group membership. I have to add those as well. And so on and so forth. So think about this. If you have accidentally deleted a whole OU structure and you're going to do this manually on 500 objects, don't think so. You really need to use a authority restore them to get everything back, because it's going to take you forever. And I bet, because I've never seen it, so please surprise me, I don't think any admin today has a full documentation of each user and each group they belong to, and so on and so forth. If you have, you are more of a nerd than I am, and you love documentation more than I do. So when it comes to object reanimation, do you want me to do it one more time, or did I go too fast? Nope.
That's good.
Okay. So let's talk a little bit about the recycle bin. Well, the recycle bin actually, in the first version, didn't have a GUI to it. So you had to do everything from PowerShell. So it wasn't that many people who used it. And it's the #1 cause for business downtime, and the #1 cause for AD recovery scenarios. So if you look at, if you see the data from support cases, when they actually performed a restore or a recovery, it's most likely because they manually deleted an OU structure or something similar. The recycle bin works both for ADDS and ADLDS, but it's only enabled at the 2008 R2 Forest functional level, and it's one way. So if you add this feature, you can't remove it. So you can, as I just showed you, you can use Tombstone reanimation to recover deleted objects without taking your domain controller or your ADD LDS instance offline. As you saw, reanimated objects linked valued attributes, group membership and so on, are actually removed and you can't get them back through reanimation. So as I said, don't rely on Tombstone reanimation as your ultimate solution to accidental deletion. So in 2008 R2, I just need some water. The recycle bin occurred, and it actually builds on the existing Tombstone reanimation that you just saw, but it enhances your ability to preserve and recover accidentally deleted AD objects. So when you enable AD recycle bin, all linked valued and non-linked valued attributes of the deleted object are preserved, and the objects are restored in their entirety to the same consistent logical state that they were in immediately before deletion. So an example, restored user accounts automatically regain all group memberships and corresponding access rights that they had immediately before deletion, within and across domains. So after the deleted object lifetime expires, the logically deleted object is turned into a recycled object, which is here, and most of its attributes are stripped away. A recycled object, which is a new state from 2008 R2, remains in the deleted object's container until its recycled object lifetime expires. After the recycled object lifetime expires, the garbage collection process physically deletes the recycled Active Directory object from the database. A recycled object cannot be recovered with AD recycle bin or reanimation. By default, the recycled object in Windows Server preserves the same set of attributes as a Tombstone object in a legacy version. To change the set of attributes that are preserved on the recycled bin object is, so how do I say this so it makes sense? To change the set of attributes that are preserved on a recycled object, you need to set the value of search flag attribute in the schema to 0x000008. This process is similar to the process for preserving attributes on legacy versions. So if you played around with the schema and the search flags attribute, I could actually go in the search flag attribute, and on the attribute I want to preserve, let's say for example description, I can put in 8 there, and when I delete it, it will actually stay. When I do a reanimation, it will come back. So you can actually manually control which attribute should be contained or not contained during delete and reanimation process. So the deleted object lifetime is determined by the value of the MSDS deleted object lifetime attribute. The recycled object lifetime is determined by the value of the legacy Tombstone lifetime attribute. So by default, the MSDS deleted object lifetime is set to null. When MSDS deleted object lifetime is set to null, the deleted object lifetime is set to the value of the recycled object lifetime. By default, the recycled object lifetime, which is stored in the Tombstone lifetime attribute, which is also set to null. So when the Tombstone lifetime is set to null, the recycled object lifetime defaults to 180 days. You can modify the values of these attributes at any time. So, but when the MSDS deleted object life is set to some value other than null, it no longer assumes the value of Tombstone lifetime. So if you don't set it manually, it assumes the value of the Tombstone lifetime. So what happens here is I have my live object. As you saw, I deleted the object. Let's see if I can do this fancy. Laser pointer, cool. So I have my live object. As you saw, I deleted it. It ended up in the deleted object. I reanimated it. In 180 days, it will come recycled object. And another time, it will then be purged. And this is where the garbage collection removes. So basically, this is the old deleted objects container, and this is the new. So the attributes I talked about. So the important ones to remember, there are a lot more attributes, but I chose 4. Is deleted. It's been around since 2000. Exists on every object. And it actually tells you that it's deleted, but you can restore it. Is recycled, which is 2008 R2, also exists on every object. It tells you it's deleted, but you can't restore it. Well, you can restore it through an authoritative restore, of course. MSD is deleted object lifetime, which is new in 2008 R2. It sets on the directory services and describes how long a deleted object will be restorable. And the Tombstone lifetime describes how long a deleted object will not be restorable before it gets actually removed from the database. And all these presentations will be available on Jammer. I just hadn't had time to upload them yet. I will do it today. So, lingering objects. So a lingering object is an object that is present on one replica but has been tombstoned and garbage collected on another replica. So I have a user X on my DC1. I have a user, I don't have it on DC2 because it's tombstone and garbage collected. This means this is a lingering object. So if a domain controller fails to replicate for a number of days that is higher than tombstone lifetime, objects might remain in the domain in the AD. Since tombstones are permanently removed during garbage collection, a domain controller that fails to replicate changes for tombstone objects never deletes or garbage collected the deleted objects. So if I've deleted a user and I haven't replicated that deletion to other DCs, it will be called a lingering object. It can actually show up again. So this can happen for a number of reasons, including name resolution errors, authentication errors, replication engine block inbound replication. The DC has been offline for a very long time, and then you take it back online. You might have changed the system time of your clock. You might have reduced the tombstone values, so it doesn't have time to replicate to all domain controllers before it actually gets purged, or incorrect configurations. So in 2003, the rep admin tool got a switch to be used to analyze and remove lingering objects from a DC that hasn't replicated for a tombstone lifetime. So rep admin has been improved, and it now includes a switch called remove lingering objects. That command will actually remove objects that are outdated, which means objects that do not exist in a replica of the same directory partition on the source. So why would this be an issue with lingering objects? Well, the lingering object is holding a value on a unique attribute that another object needs. That's one issue. 2, it's a security risk. So let's say I was a consultant. I was at this company. DC1 has been offline for a while. I've been removed. DC1 is back up. And I log on. I come to drink coffee at the customer, and I just try to see if my credential works. And I'm lucky. DC1 is actually getting my authentication request. And since I'm a live user there, I'm on the network again. So that's one of the security risks. Another thing is email messages are not delivered to a user whose object was moved between domains. So if you bring an outdated DC online, both instances of the user object appear in the global catalog, and both objects have the same email address, so emails cannot be delivered. Another thing is the user still exists in the global address list. You might have a universal group that no longer exists, but still appears in a user's access token. So it's a bad thing with lingering objects. So how does it work? It's about replication consistency. So an object will never be considered for replication if the attributes on a lingering object never change. But if an attribute changes, it will be considered for outbound replication. The problem is that the receiving domain controller doesn't hold the object for the attribute being replicated, and an update cannot be performed. How it will deal with this issue depends on replication consistency set on the domain controller, and there are two choices, loose and strict. So I'm going to go back here. So let's say someone goes in, let's say through a script, and update area code on every phone numbers or something. This user will have a new phone number, for example, or address. The USN numbers will talk to each other. This DC says, no, I don't have this user. So depending on loose or strict consistency, the user, which is supposed to be deleted, will actually be replicated back and seen as a new object. So have that in mind when we go in to discuss loose replication consistency, which is actually what I described. So if replication consistency is set to 0, which is loose, the receiving domain controller detects that it doesn't have the object for the attribute that is being replicated. The inbound partner requests the entire object from the outbound partner and reanimates the object. The same process will then be repeated on all DCs that do not have a copy of the object. So let's say we have DC3, DC4, DC5, DC6, and they don't have the object as well, and they replicate with 2. And since 2 think this is a new object, DC3 will also think this is a new object, and DC4 and DC5, and so on. So, whoa. Oh, there we are. So, actually, the mechanism of having loose replication consistency can be useful to cause lingering, when you have lingering objects that you need to reanimate across an entire forest. So if you discover a lingering object and you need it, then perform an update on the object, and that will cause an outbound replication. And as long as the replication consistency is loose on all the DCs, the object will be reanimated as it replicates in the forest. Strict replication consistency. Because of the issues described earlier, the default setting is strict. This means that the inbound replication per naming context will be blocked when a domain controller receives an update to an object that it doesn't have. Replication is halted in the naming context for the object until the lingering object is removed or the replication mode is set to loose. So you see the register value on your screens. The name is called strict replication consistency, and it's a reg D word. And you have 2 possible values, 0 and 1. Value of 1 indicates strict replication consistency, and 0 indicates loose replication consistency. Detect DCs that haven't been replicated. So in Windows, there is a record for the last time a DC has replicated, directly or transitively. Periodically, each domain controller will compare the last time a domain controller replicated with the forest tombstone lifetime, and if a domain controller doesn't replicate within the tombstone lifetime. So an event is shown in the DS log, NTDS replication event ID 1864. While in this state, the DC tries to replicate, the inbound domain controller will block replication and alert the admin of the message event 2042. So if you see event ID is 2042, you might have problems, I would say. If this happens, you have a couple of options. You can reinstall or forcibly demote the DC, which has not replicated, and then you perform a metadata cleanup. You can remove the lingering objects on the non-replicating domain controller and then enable replication, but you also need, and this is the coolest name of a registry key ever, you need to set a registry key in the local machine system, current control set, services, NTDS parameters, and the name of the key is, hold on, allow replication with divergent and corrupt partner. Just the name says it all. Allow replication with divergent and corrupt partner. So that's a key that basically says it all. You, with your, it's a long key name, and if you type it right, you should know what you do. You allow replication with corrupt and divergent partners. So be careful about that, but it can be a lifesaver. So replication errors, there is no way of being notified by the presence and replication of lingering objects if a DC is replicated within the tombstone lifetime and replication consistency is set to loose. As long as an attribute is changed, the object will be reanimated by all the DCs silently. But if you have strict replication, the replication of the partition hosting the object will stop until the object is removed or replication consistency is set to loose. So when the replication is stopped, you have an NTDS replication event 1988 that is written to the DS log on the inbound domain controller. You can also use the repadmin show REPL that will show that the lingering object is being sent. So what to do? Existence of a lingering object is in most cases the result of a missing tombstone, which means that an object was intentionally deleted because one DC received the instruction to delete the object. What you should do with a deleted object depends on whether it was intended or not. So a DC has not replicated beyond the tombstone lifetime. If the domain controller has not replicated within the tombstone lifetime, it will likely have missed the deletions of some attributes. If the object is left alone, it will persist without any replication, but if any attribute changes, or if another domain controller do a full sync, the object will attempt to replicate out and cause issues. There may be cases where a user or computer object has become a lingering object without any known cause. In most cases, these are undesirable, but before removing them, check the event log and see what object is being replicated in. If this is what you need, then turn on loose replication consistency. If the inbound object is a deletion, it is in most cases harmless and not needed, but if the deleted object still exists on another DC somewhere else in the forest, removing this lingering object will make the other live copy a lingering object. So if we have an intended, then I suggest you use loose replication consistency on the inbound DC. This will reanimate the object on the DC, but before you do that, consider a couple of things. As soon as the object is reanimated, it will be replicated out to all partners, and it's likely they don't have the object, and inbound replication will be blocked. To fully reanimate the object, it may be necessary to chase the replication failures throughout the forest, and I would suggest use EventComb MT to monitor the event logs. I will show you those tools later as well. So it is possible to turn off replication consistency in the domain or forest, but this can have some unwanted effects and replication is blocked for the first lingering object. If it is an unintended lingering object, you have to use repadmin remove lingering objects. So what happens when you actually do repadmin remove lingering objects? Well, it will record all of the lingering objects, removal activity. It will tell you the source domain controller, what objects has been removed, and the total count of all removed objects. So if you have thousands of lingering objects, your event log will have thousands of entries because it will say, I'm now removing this object. This object has been removed, and so on and so forth. So it will take up a lot of space. Repadmin. So the command in itself uses a reference DC, and the contents of the reference are compared to the domain controller that you suspect having lingering objects. So if it finds an inconsistency between the two, the object will be removed. So how does a lingering object check actually work? So first, the destination DC queries a source DC for its up-to-date UTD vector for the naming context specified within repadmin. So you need to do this per naming context. 2, the source domain controller returns requested UTD for the requested naming context. Based on the sources and destination's UTD vectors, destination determines the set of AD objects that should be present on both source and destination domain controllers. Destination domain controller breaks up the entire content of the NC, which is step 3, into subsets of 1000 GUIDs. Each subset contains all objects from the NC that should exist on both. Each GUID subset has a range specified by the GUID min, that is the lowest, and the GUID max, which is the highest GUID in the set. So for each subset, destination DC calculates checksum based on GUIDs of the object in a subset. Destination DC then sends the source DC the checksum, the range, GUID min, GUID max, its up-to-date vector, and the naming context in which lingering object removal operation is performed. So similar to step 3, based on the source and destination's UTD vectors, source determines the set of AD objects that should be present on both source and destination DCs. Source domain controllers calculates checksum based on the GUIDs of the object within the range on its own set calculated in previous step, which is what I said. Source domain controller compares checksums calculated on source and destination. If they match, it sends an acknowledgement and a request for the next set. If they do not match, then a direct comparison is made on each object in the set. And at this point, if a lingering object are discovered, they will be deleted. And this process will continue throughout all the checksums are compared. In the old days, from 2003, there was a tool called DSA Stat that could be used to compare replicas of the AD database, and you could see actually how many objects it was in the local DIT, and you can compare those. That tool is unfortunately gone. It was really good, but if you would like, I have a script that can do the same thing. So just send a post on Yammer or something, and I will share it with you. So we got 8 minutes left. I'm going to do another demo. But not on that machine. How do I get rid of this laser pointer thing? So. Let's do this. So if you use the rep admin and you type help, it will not give you much. And it will absolutely not tell you the cool commands. So the tip is to use expert help. So in order to use these lingering objects, and you can allow replication with avert and corrupt partner. You can set strict replication consistency, remove lingering objects. What you need to find this help, it's called expert help. And then you just type remove lingering objects, and you will get the examples exactly how you do it. And another thing I wanted to show you is not Event Viewer, which I actually forgot. So let's do this. Here I have a user called Jimmy Anderson. I have some information, not much, but I'm a member of domain admins. And this is with recycle bin. So let's go into sorry. No matches. Huh? Show X free. Enabled, it's enabled. I don't know your customers, remove that. There you go. No, it hasn't found me yet. So this is the recycle bin, and if I go in here, see this is the same LDP I used before, and I have a lot of deleted objects here, so it's going to take a little while. As I showed you before, I need to check in if I want to find my deleted objects. I have Jimmy Anderson. And if I, as I also told you, there is another, I can see my recycle objects. And as you see, so let's do this. You can actually have a number of controls in at the same time, so you can mix them. But that's not the cool thing. So if I want to take somebody back, I just right-click it and restore it, or restore to, and that is the equivalent of using the DN value. But I'm going to do what I talked to you about. Let's do customers 2. Now we do this. We take New York. Hello. Where is it? Oh, there it is. The test user. I have something on it. It's member administrators. And I do a oops. It's kind of hard to do an oops when you get an extra window up. Are you really sure you want to do this? Yes, I'm in a real oops state today. So as you saw, the whole structure called global infra was deleted. So if I want to get that back, I need to do this. There you go. Thank you. Since I have played around with this last night, I have actually, and this is in Swedish because it's an old script that I did for a demo. So I have a tree with this, more than one tree with the name Global Infra. So it asks me which one do I actually want to return. So let's see. We want to return this one. So I take the GUID, copy the GUID, we do create and delete, we do identity, I do paste, and I do a delete backwards. I get my top OU, the children of that top OU, and so on, so on, so on. And here I have my test user. Let's go back. Let's update this. I got my global info, I got my services, my ADFS service, I got my user, and I got my membership as well. So instead of using an authoritative restore, let's say I have thousands of objects, and I can either do it, one by one here, which I also need to understand who was the parent. I need to find that, and there's no parent for that one. Or I can do it here manually, one at a time. You can either do a authoritative restore, or you can actually use this script, for example, which is much faster. And I will not share this script with you because Simon on the PowerShell day, he has taken this script and evolved it to do some really pretty cool stuff, and he will share his script with you guys. So I just wanted to show you how the difference between the recycle bin, you get all the object exactly as it was before you deleted it, you get it right back up. So by that, I think my time is up. Thank you so much.
Thank you, Jimmy. And thank you for keeping the time. And it was an awesome presentation. We are taking a 30-minute break, and then Lasse will continue with Exchange and stuff.
We are back 10:30.
10:30.
Okay.
Thank you. Bye-bye.
Bye.
Thank you. Bye.